Of the IBac from 2023, the AA bit, and we have a velocity time graph with this formula, and the first question is find the displacement of the object at from the origin at t equals 1, the origin being there. So what we're going to do is, if we're going displacement, that means to integrate. If we're finding acceleration, it means to differentiate. So we're going to take this number here and we're going to differentiate it between 1 and 0, and I'm going to write it out first. So let's differentiate it. So we're using the brackets, so we don't need to put in a c, and we raise the power, so it's minus t to the 4 over 4. And then we raise the power of t squared to t cubed, and we put the 3 underneath and we make it 6, so it's 7/6. And then we raise this to t squared and we put that under, and then 2 over 2 would be 1, so we don't bother with that. And then we put in t there. Now we've got to find it at the time 1. So we're going to put 1 into here and we get minus 1 over 4 plus 7/6 minus 1, because 1 squared is 1, plus 6. We're going to put all that into our calculator. We're going to play about a bit and we will get 71/12, which is almost 6. But it's actually 5 and 11/12. Right, now let's find an expression for the acceleration of the object. So what we're going to do now is we're going to take v equals minus t cubed minus plus even 7 to the c squared minus 2t plus 6, and we're going to differentiate it. So that would equal, bring it down and put it in front. So bring it down to 2, so it's minus 2t squared. And then bring this down, so that's minus 3t squared. Bring the 2 down at the front, so that's plus, that would be 2 over 2, so that's 7t. And then bring this down at the front, and that's just minus 2. Right, so that's our v squared, so we've done that. Now hence find the greatest speed reached before the object comes to a rest. So at that stage, that's when the acceleration will stop. So we're going to put 0 in front, and we're going to go minus 3t squared plus 7t minus 2 equals 0. We're going to times it by minus 1, so we get this. And then that is solvable, I think, with 3t, and that's going to be minus 2 and plus 1. So minus 2 and minus 1. So that's at the time that t equals 2 and t equals a third, which is good really because you can't go backwards in time. So that's going to be the greatest. So we've now got the time when that works, but we haven't actually got the speed. So we know that that's what t equals. Now we're going to have to put that we're going to have to put that back in to, so put 2 into the normal thing there, and that's going to be minus, so it's going to be minus 8 plus, so that's 4 over 2 plus 14 minus 4 plus 6, which is 10. So let's just check that. Speed. So that'll be 2, so it's 2 cubed. So minus 8 plus 14. So it's 4. T8, 14. Minus 4, that's 10 plus 6. Yep, that works out as equals 8 meters per second. So that's our answer for there. Then find the greatest speed reached by the object for during the time 0 to 4 seconds. So let's have a little look. So if we know what happens at 0, then we could also have a little look at what happens at 4. So also it looks around there, so that makes perfect sense. So if we put the 4 into this again, we would get minus 64 plus 56 minus 8 plus 6 equals, and then that would be minus 10, which is 10 meters per second. Okay, and then finally write an expression that represents the distance travelled by the object while its speed is increasing. So that would be the period when its speed is increasing. So that would be between t equals a third and t equals 2. And then it would also equal, hang on, so that's there. And then it sort of stops and then it goes up again. And then it would be t equals k and t equals 4, because we don't know what the other one is. So that would be between 4 and 5. So it's basically between 4 and k. So we could use 2 to the third of v t dt plus 4 to the k v t dt. And that would give you the answer.